Good afternoon. Welcome to the stream. Don't see anybody in here yet, but we'll get started real soon. Gonna do some more game dev in Bevy today. Continue to be excited about this. I think there's a lot for me to learn still, and yeah, and I think I'm kind of having fun. I hope you are, and I hope that keeps bringing you back to my stream. And we'll get going in just a few minutes. Let people come on board, and I'll check out the settings on my Twitch page, make sure everything's okay. Let's see. Yeah, so yep, looks like we're looking good. All right. Okay. And we're not dropping frames like last time, so that's good. All right. So, looking at our to-do list here, let's go ahead and switch over. So we've done a lot on our game so far. We handled collisions, we handled weapon damage, enemies giving damage to our character. We have knockback. We've got some really neat stuff going on so far. But we're kind of running on a blank background. And this wonderful tile set that we're using, the Kenny Tiny Dungeon, has background tiles. So I thought it might be neat to do a few things. First, and these are our notes from previous sessions about what we want to do. I think what I want to do is build the outer boundaries of the game space. So basically, we'll start working on the map. And the first thing we can probably do is generate walls. So we can do horizontal and vertical walls on the boundaries of the game, and then we'll look at putting down some ground tiles. And it'll be interesting because the ground tiles are not things that we want to collide with, but they are sprites, right? So we'll need to think about how to make that make sense. Maybe we can do something like I don't know, like a special material. I don't have much experience with that, but there's actually a question on the Rust Game Dev subreddit this, like, I think yesterday or something. Anyway, I replied to it saying, our friend Chris Biscardi's YouTube channel has some great examples of doing doing custom materials. A lot of his stuff, like the shield bubble, the noise based height map, those sorts of things we're able to do with custom shaders in Bevy. So maybe we'll look at something like that. Maybe we can do some random generation of the floor tiles. But we'll see. I think the first step would be let's get in there and load some tiles, kind of make some decisions about how big the game space should be. And so this would be like enemies and player can't go outside. So we need to make some adjustments to how our enemies spawn, make sure they don't spawn outside the walls. And we'll need to do a little bit of camera work so that we follow the player. So maybe we'll talk about that as we go. But let's get into it. Okay, so last time we were looking at the health stuff. I don't think I want to change anything right now. Yeah. So let's look at let's look at this reveal in Finder. I want to look at the preview. So it's interesting. We have lots of different kinds of wall tiles. You know, things with doors or portals. Looks like stairs, actually. I don't think we'll want that. We might want... that's going to be hard to say. Let's look at their sample and see what they're doing. Okay, so on their horizontal walls, they're using this brick texture, which I think is good. And then at the edges, they're using one of those corner textures. And then on the vertical walls, it's just the thinner line. So let's look at those tiles again. Okay. So they've got tiles that have bricks on the inside and tiles that have dirt on the inside. And you can have... Interesting. Yeah, so let's try to make... Looks like these are the edges of the walls. Is that right? Yeah. So these two are edges. This looks like a thinner wall. So if you had a one cell wide wall, it would be this. If you have more than one, it would be some combination of these and the brick texture. And then, yeah, and so then you would have stuff like this as the top of the wall, or this potentially. Cool. Yeah, let's get started on this. I have to admit I'm a little intimidated, but we'll figure it out. So this, let's look at the tiles. So that's like the dirt. This is the top of the wall. Maybe we can start getting these in our asset loader. First, let's open the asset loader. Okay. Get our windows arranged here. Okay, so we're gonna do... Let's just put these in comments for now. So the wall top is going to be 002. And then, yeah, top middle. This will be top left is going to be 1. Corner. Okay. And then we have the top right corner. This will be 3. Get these lined up for now. Okay. And this is, I guess we'll have vertical edges. Let's look at this one more closely. Yeah, I'm gonna have to look at the preview again to know exactly. Sometimes in the past I've used these tile maps and they have like a yeah, I don't know. That's not that useful. Sometimes they had descriptions of what the tiles are. That was in a different set of tiles though, so I don't know that they're gonna work for this. Okay, so these are all horizontal walls. Horizontal. Okay. And this, oops, got a little bit too ambitious there. Tile 14. Okay. Oops. So we're going to have horizontal wall face is going to be 14. Okay, and then we're going to need a vertical wall. So it looks like we've got these. It looks like 4 and 5 are kind of the connectors on the top side, right? So like these that I used earlier, these would be like a front face. So maybe, yeah. And then these would be a back face. So like on the, if we have a wall in the middle of the game space, this would be going around the top part of that wall. When I say the top, it would be like the furthest to the north, if we're going in cardinal directions. Okay, so let's say vertical wall left or right is going to be tile 13, right? And vertical wall left is going to be tile 15. And I don't think that's it. Yeah, and then there's some corners and things. Got bars on the wall. That might be an interesting variation to throw in there. Let's get these in first. And I think I want to make a wall sprites, and we'll put this in this, and it'll just be a sub. This is gonna be wall sprites. Okay, so we're gonna say v wall left is, and these are all going to be handle image, right? Just like before. Image. And let's do v wall right. And I'm kind of a little bit going in backwards order here. Let's do h wall face. And h. We're going to need more than those, I think. We might need corners. Maybe we'll try it out and see. Top, mid, top, right, and top, left. And I think what we should do, so this needs an implementation of default and debug. So I'm going to copy this, but it's not a resource, just being contained in there. Okay, so we're going to say wall sprites. Okay, we need to fill that struct field out. Okay, so now we can go, we just move this down now that we have it. Put it here at the bottom. And at some point we'll probably need to get, I'm going to copy this a bunch of times. I was going to say at some point we're going to need to get probably Bevy asset loader, so we can have progressive loading, and then like not start our game until everything is loaded. The other option we could do is switch to the packed tiles or something, or the ones with borders, and then just use offsets into this. The packed one might be good. That'll require a restructure of the entities, though. We'll need to use a sprite sheet instead of a plain sprite. I think the plain sprite is a bit easier to understand. Let's see, we are still too big. I want to go down a size, point size. And we'll leave that at 10. Okay, that's better. Okay, so for the top left horizontal wall, we have 1. The middle is 2. Top right corner is 0, 3. The horizontal wall face is 14. And then the left is 1, 5, and the right is 1, 3. Okay. So we'll get those in there, and we can. Now that we've got some images, we can go back to adding stuff to our game. So like before, I'm going to make a new module. And for now, let's call it map. For lack of a better word. Hi, Isaac. Welcome to the stream. I had a great start of the new year, and Happy New Year to you. Prelude star, and here we go through this dance again. So, map plugin. Okay. And okay, and I think what we should do at first is maybe what we'll do is we'll build a wall. And we need to kind of think about this as like more discrete than we've been doing. It's fine for the movable characters to kind of flow around the screen wherever they want. But our map pieces should be on a grid. And so what I'd like to do, just to test out, do our sprites look correctly as they're attached to one another, is let's make a really simple kind of map tile. Let's figure out what the grid is. Obviously these sprites are 16 by 16, so that's an easy place to start. And then let's put a wall in the middle of the scene somewhere. And that way we can get an idea of, does it look right? And then we can refine that. Maybe what we can do, instead of having, because right now what I'm thinking our initial one will be like 1 entity per tile. That's not going to scale. I know we kind of like falling on the themes of entities, lots of entities, but maybe what we can do then is if we make walls that are not I'm gonna try to say if they're like 1 entity per wall segment, right? Like big rectangle, right? Then we can selectively choose the tiles based on the location. Maybe we'll get into the renderer. This is going to require some research that I haven't done yet. So that'll be fun. But for now, let's just make a silly little wall in the middle of our screen that has multiple tiles. Okay. Yeah. So we're going to say add systems. And the schedule is going to be post startup. And we're going to say add wall. This is going to be our first one. Function add wall. Okay, and this is going to require commands like before. And we're going to require the assets, the sprites. Sprite. Is it sprite assets? Yep. Okay. And I kind of want to go maybe let's draw a little diagram of our, or take some notes about the size of the space. If we're 16 by 16 for our sprites, I don't know. Let's pick a small space for now. Let's say our map is 250 by 250. So that's actually, multiply that by 16 for in terms of pixels. This is going to be a really small space, honestly. But we want to say, so this would actually range from negative 125 to 125 in each dimension. So let's spawn this. So we're gonna have to do some like transform calculations, right? So maybe let's make a which is a space which is grid to world, and this is going to be a really simple, just say a position. We'll say vec3, and this is going to return a vec3. And maybe this would be like, what is it? Is it ivec3? Which is the i32s? Yeah, that should be fine. So, because that's plenty of space to store 250 by 250. Okay, and this should be pretty straightforward. What we will do is take this position and multiply it by 16. Not 15, 16. So that multiplies it in all dimensions and convert. Now, that's a pretty dumb one. That doesn't work. Maybe let's just say vec3. And we don't care. Multiply by 16. Yeah, I don't know that this function is that useful. I don't think that we want to have this everywhere. And if we want to change what this looks like, then yeah, I should be looking at glam again. Sorry, got dash up over here. Bevy. We got Bevy math, I think. Math. Yeah. So if we have ivec3, do we have a converter into vec3? Probably not. I say as vec3. Yeah, that works. So I like the idea of using integers for the grid. So we say like this as vec3. Okay. So this will let us say like something like, I want position, 2 to the right and 4 down on the grid, and then we can convert it to the world position. And maybe we say position times 16 dot extend 0. Then it can actually be a 2D position, and then we convert it, to 3D. Okay. So let's make a wall. Let's make our first wall, and let's say its top is 2, 0. So it's going to be on the horizontal axis, 2 to the right of where the player spawns. And that's going to go, let's make it a horizontal wall to begin with, because I think that's going to be the easiest to think about. Let's make it go over you know, 4 places. So 6, 0. But it's also going to need a top. So it's probably going to be like, it starts at 2, 0 and it goes down to 6, -1, so you can have the top part of the wall as well as the center part of the horizontal wall. Okay, so we're going to do, I was going to do in a loop spawning this entity. So this should give us 8, right? Yep. So we're going to say for x in 2.6 equals 6, because we want to include that, and y in 0, -1. So we'll do command spawn, and this, whoa, I don't know what that is. Just wanted to get, okay, so we're going to need a wall component, and this is just a marker, right? Clone copy, that's good. We want actually -1 to 0. Good call, Clippy. Okay. So I think we want to do something like, let's figure out which sprite we want, or which tech, because it's texture in the bundle. Let's do a match on XY, and we're going to do, so if we're at 2, -1, we know this is going to be that edge of the horizontal, the left edge of the horizontal. This is not really generalizable. I think at some point what we'll do is like go with, this is a rectangle, and then we will, you know, in the shader or the render, pick out which tile to use. But if we're at here, what we want, let me switch back over to asset loader. So we want the, oh, we didn't add the horizontal wall edges, right? This is part of the problem. So this is going to look bad if we're going to use corners. Let's maybe start with the ones at 0, because we know that this needs to be the top left corner. So we'll say sprites.wall horizontal wall top left. If it's at 6, 0, we know we want sprites.wall.hwall top right. And then anything else at 0, we want top mid. And then if it, for now, this is not going to look right. Bear with me. It's not going to look right. But we want the horizontal wall sprite. Face. Okay. And let's do clone on that, because we want to put this handle into the sprite bundle. So we're going to say this is sprite bundle, and we want the texture, and then we want the transform. This is going to have a wall in it. The transform is going to be transform from translation from translation. There we go. And here's where we'll do grid to world. X, Y. And then we want the defaults on the rest of that. Okay, and I'm gonna remove the split over here. Okay. And for now, I don't know that we need to do anything else. What's wrong there? Doesn't implement copy. Okay, I think I'm gonna have to put this clone on each of these. I was hoping not to. I would think that this would end up being a reference. Here. Let's put references on each of those and see if that works. Okay, it's not complaining about that. I don't know that I like that. I would expect that because this is, you know, is a struct that contains a reference, that this deref would come out. Okay. Well, let's move forward. Okay, so we should have spawned a bunch of sprites. They're not going to do anything yet. Maybe we want to put colliders on them. And that may depend upon... remember, we have a size, which is a rectangle, on the collider. But let's do that. Let's do that second, because that's not really that important for now. So let's see if we can still run the thing. Oh, you know what we didn't do? We didn't add our plugin to the setup. Map plugin. Now it'll actually spawn the wall, we hope. And it's not going to look right. I guarantee it's not going to look right. Okay, so you can see here we've got problems. First of all, we're spawning it on top. But you can see that, you know, the top of our wall looks okay, but the face of our wall, it should come to a line there. So let's figure that out. I think the answer is we just need more sprites. We need the right ones, the right tiles. Okay, so are they further down? Is this actually supposed to be the correct wall texture? I think it is. Let's switch that horizontal wall face to 40. And then where's the edges of the wall? Here we go. Okay, so 57 and 59 are like the wall face edges. Hi, Chris. Welcome to the stream. I am always trying to promote your stuff, by the way, because I think what you do is awesome, especially on the Bevy stuff. So you've already got a shout out today. Welcome. Okay, so let's instead of... The interesting thing here is that if you look at what... we'll go ahead and make that switch and run this. But if you look at what's going on here, this tile is like, you know, you can see when you get the character close, this is 16 by 16, this corner. And which makes me think that, so we won't be able to put this wall edge like right here. We'll have to offset it or something. And I don't know. I might turn off the firing systems for a minute. But we don't, like, this is only, you know, a few pixels in from the edge of that tile. And so if we look at if we look at this tile, you can see that it's mostly over to the left. And so we're going to do some problem solving there. The other option is potentially that we didn't use the right. Maybe we want these. No. But anyway, I guess my point is maybe we didn't use the right border tile on the edges of the walls there. Yeah. I don't know. Let's think about it. The other thing is, do we want? I've still got this running. Do we want? Oh yeah, my character's dead. Do we want these to go, like, to extend over to, like, partial grid elements? I don't know the answer to that yet. Now, what we could do, since this, we'll do a horizontal thing first. Maybe what we do is don't bother about corners. Ooh, I panicked. Did I run out of memory? No, I didn't. I panicked on there's no player. Okay. So let's, instead of this, now that we've got this example going, let's put this at the top boundary of our screen and make it go from, from the left extremum to the right extremum. So so we're going to say the x is going to be negative 125 to 125, and the y is going to be at 125, 124 to 125. This is like, I think we'll probably pretty quickly want to go we'll probably pretty quickly want to make a generic thing for this, like a function. It's like horizontal wall, and here's all the entities. Although I'm kind of feeling like, do we really need all these entities? Maybe I can drag Chris on Discord and we'll talk about how to make custom materials for this goop. Anyway, okay, so we're gonna simplify this. Doesn't need to be a match anymore. Okay, if y is 124, and then what we want is the face. Else we want the top border. And we'll do this. Yep, and get rid of that. Okay. And then, yep, let's run that. And the thing is, I think we're not going to be able to see it, right? Because it's off the screen. Let's change. Oh, you could also do tile map like Bevy ECS tile map or ECS LDTK. Yeah, we could look into that. I'm not yet wanting to actually craft the levels. So I don't know if you could specify just data in those, like, by hand. That would be ideal for me right now. Let me turn on the fan. It's a bit warm in here. Yeah, I'm generally okay with third-party crates on this project. Mostly just wanting to learn and have fun. Because, well, we've got Bevy and we've got Rand. But yeah. Okay. So I think let's put this at 1 to 2 for now so we can see it. And then we'll think about how to make the camera move with the player. Okay, we're gonna have to fix that panic. Okay, so you can see we've got this wall and it goes forever. You know, and of course our character is not clipping correctly with it, but so like that's looking okay. I don't really like spawning an entity for every single tile. So let's have a look at Bevy docs. One thing I would like to do is let's look at the sprites stuff. I suppose we could do, I'm not sure if this is the correct thing. No, that's just a marker component. So our sprite bundle defines this sprite. Rect. Okay, so you can render a portion of the sprite. So if we wanted to get those borders on our wall, we might do something like that. Oh, okay, so they're saying this is one-off alternative to using text or atlas. Maybe that's not what we want. Okay. The other thing that we can do is I was going to say, you know, our problem with having the wall pieces be on the same level as the player, we could potentially put this as like negative, no, it'd be like 1. And then it might render below. Let's try that just for, no, that's wrong. I don't remember if positive Z is toward you, if it's right-handed or if it's left-handed. I think it's right-handed, so maybe we'll try -1. And see if that'll render the wall below. Yeah, okay. So positive Z is toward the player, or toward the camera. Okay. So like that's actually kind of cool if we did something like, you know, the wall, we want the player to be able to kind of overlap with the wall a little bit, I think. And maybe that can be part of our collision detection. Okay. Let's look at our camera. Right now we're only spawning the camera on startup, but I think what we want to do is figure out a way that the map and the camera intersect, such that we can move the camera so that it follows the player up to the point where they hit the edge of the map. So let's just make a system follows player, and we're gonna have to do some calculations in here, but we want the player is, we want the query transform, and I'm thinking we will want to, in our map plugin, make a map resource, which will tell how big is the map, and what's the scale, which right now is constant of 16. But this will be with player. And then, so the camera is an entity, right? Probably want the camera 2D component. And I don't think we're going to want, this is going to be mute, right? Because we want to adjust where the camera is positioned. And then let's start with that, because I don't think that we need to do the, make sure that you're the left or rightmost or top or bottommost edge of your view, which in case we might need the projection to compute that, is like doesn't go beyond the left side of the map or the right side of the map, so forth. But we can do that in a minute. We'll make the map resource, which is like how big is our map, and then yeah, and then we'll make use of this. So we need the player. And I think that's a good place to start. So player, did I get single? I don't want this to panic if the player dies. So we're going to use the non-panicking version. Okay. So that is not what we want. That just has the clear color. So let's look at the camera 2D bundle, see what it includes. All right. Okay, so the camera, I guess we want the camera's transform. Right? Yeah. Okay, so okay, and we had played with the projection before, I think. Yeah, okay, so I think what we want is we want the transform to be mutable, and then we'll just pick the thing that has camera 2D or camera on it, right? Okay. Yeah, the camera's transform. Okay, so we want the transform with one thing that has camera on it. Okay, so we got the player transform, and then we want to say camera. This is okay, I think, to do with the panicking version, because we should always have a camera. So this should return the transform. And let's just set them equal. And this should run on update. This is camera follows player. And I think we'll do inset entity updates. Okay. And this needs to be What's going on here? Oh, this returns a result. Let's just do okay. I was going to say dot okay on that, but that's silly. Okay. Let's do it like this. Transform translation was player transform dot translation. What's going on there? Okay. Sometimes when these generics come in here and it can't figure out what exactly is that Q item. Is it mutable or not? It can't figure out. So giving it a little help. Okay, so let's run this and see if we get the camera following the player and our stuff doesn't blow up. Oh, it panicked. Okay. So interesting. So query, I've never seen this before. Our query, the transform, accesses components transform in a way that conflicts with the previous system parameter. Consider using without T to create disjoint queries, or merging conflicting queries into a param set. Interesting. Okay. Querying the same components without differentiating the sets. Okay, so can we just throw without player in here? That doesn't work. The other thing I could do here is go put camera in here and say without player. And then we can just ignore the camera. Yeah, multiple filters has to be tuple. Oh, inside the, okay. Yeah. Oh, you mean it can be like with camera, like so, without player. Is that what you're saying, Chris? Yeah, without. Okay. Okay, let's see if that doesn't crash. Okay. So, cool. So now our camera follows the player. That's pretty cool. That was pretty easy to write as well. Good stuff. Okay, so let's look at defining the map resource. Debug. And we're going to say this is going to have dimensions, which is going to be an IVEC2. And then tile size, which is going to be a U32. And then, you know, we could actually make this be a rect, I think. For now, let's go with this, and then I'm going to say Add resource. Is that what it is? Resource. Insert resource. And we'll say IVEC2 125 by 125. No, 250 by 250. And then we'll do some math. And the tile size is 16. So now we'll have the resource there. These need to be pub. Okay. So now in our camera, we'll import this resource. We'll import grid to world. And maybe what we'll do is we'll figure out what is the, we'll check the top, bottom, left, and right of the viewport. And stop scrolling if we get close enough such that like the left, say like the left edge of the map. So if your character's moving left, the left edge of the map, if that is the left edge of the viewport, then we don't go left anymore. Okay, so we've got that. Let's put this on a new line. Whatever. Okay. Camera. Okay, so we're gonna use that, and we're gonna have map grid to world as well. And we actually need the let's start with that, right? Okay. So the question now becomes how we get what the bounds of the viewport are. And now the other thing we could do potentially is we need to know what the viewport dimensions are, and I think we set that up in our main. We set it 800 by 600, right? And that's pixels. We are scaling in the camera plugin. So we're setting the scale to be a bit bigger. So that's in the projection. I wonder, can we use the projection to compute something? We get a projection matrix. I wonder if the frustum corners are what we want. Let's look at this a little bit more deeply. Yeah. Viewport origin. Oh, okay, so this is actually what we want, right? We can look at so this rect is the area that the projection covers relative to viewport origin. So the camera system automatically updates this value when the viewport is resized, depending on the other fields. In this case, areas should not be manually modified. Okay, but we could do something like because this we've used this rect before in our collision system, right? Um, okay. So we could do something like this. Let's see. And the main thing we would want to check is, does it contain a particular point potentially? Um, yeah. Okay. Because what I want to do is figure out, and we can probably try to do it brute force first, um, and just look at the top, the left, the right, and the bottom, and um, so we might want to make a few little methods here on the map, like so maybe hmm, I don't know about that yet. I'm sorry, we're vacillating and not we're a lot. We're not really writing code here. So let's just go and check. Um, so if we're off at the left, um, what's the half width of the map? So we have map dot dimensions. Excuse me. Uh, da, 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 da. So we could say the top left. So it's the half extent, the negative of the half extent, right? Okay, and then the bottom right is map dimensions by 2. And we want these, we'll do our little trick like we did earlier as vec3. We'll do that on both of them. And then we can maybe use those to compare against the transform. We'll probably pick out individual dimensions, except this is not correct. We actually want our grid to world. That's what we want. Hi, Tuxified. Happy New Year. Welcome to the stream. Okay, I figured this function would be useful. Okay, so now we have the top left corner and the bottom right corner, except that's not correct. That's actually not the top left, is it? No, because positive goes up. So both of them negative. This would be bottom left, and this would be top right. Right-handed coordinate system, remember? Okay. And really, we just wanna know what those dimensions are. Okay, in world space we want. So let's just go through a bunch of ifs, and I'm gonna half dimension. I'm gonna go ahead and do this. Because we need to get, and I just want one of them. I don't care which. No, we'll do this because we're gonna have to use X and Y probably. Okay, so what I want to do is check if the, oh, but we don't, I'm sorry, we don't need this. We need the dimensions of the viewport. So let's, for now, let's comment this out, and let's just info print some stuff so that I can understand what's in here. And we are going to have to get that projection out, weren't we? Yeah, we want to get the orthographic projection. So let's put that in there. Orthographic projection. Okay, and then we're going to do this projection. I want to see what the projection dot area looks like, because if it moves with, oops, that needs to be borrowed. If it moves with the camera as we move the camera around, I want to know that. But if it's like constant based on the projection of the, then what we'll want to do is like take the dimensions of that area and combine it somehow with the camera translation to figure out, you know, are we at least halfway away from that edge? Okay. Very complex type use. Consider factoring parts into type definitions. Yeah, we're probably going to get that. Okay. So that looks constant, right? That's good to know. Okay, so I think what we can do is do something where we take the camera's translation, and clamp it. And maybe that's simpler. Maybe what we can do is compute the maximum bounds of the camera's translation, and then clamp with that. Yeah. Yeah, I'll disable those at the module level. Yeah, or maybe even the crate level. Yeah. Link deleted. So that warning is that a Clippy? Yeah, that's Clippy type complexity. Yeah. Let's just do that here in our camera. Let's say allow Clippy type complexity, and then it won't care. Yeah, unused variables is fine. We'll fix that in a minute. Okay, so the projection area is not changing. That's like the viewport. Oh, and cargo.toml? Yeah, that's a good call. It's a lints like field in cargo now, isn't it? I don't remember how to do that. We'll leave this for now. Come back to it later. Okay. So we want to we want to bound the camera. So it actually needs to be a smaller rectangle than the rectangle of the map. And I'm starting to think about Minkowski goop. And I don't need to think about this. This is way simpler. So if we think about like half, or say like a quarter of the dimensions of the rectangle, okay. Let's again. We're gonna do some brute force math here. But I'm gonna have to talk my way through it. So bear with me. Okay, so we computed these world dimensions, or these world coordinates, of the bottom left of the world and the top right of our, I'm sorry, the bottom left of our map and the top right of our map. And we want, so let's do some brute force stuff here. So projection dot area, we want to get what is the max camera position, and we want to get the min camera position. Right? Okay. So what would be the max? The max would be the top right and then we want like a vector that points to the max. Well, that's just our vec2 on the area, right? So we want to subtract max, and we'll extend it with 0. Okay, so now we've got it's like inset from the corner, right? By half the distance, or half the dimensions of this visible rectangle. Okay, and then we'll do the same, except it'll be yeah, and it'll still be minus, but it'll be area dot min extend 0. Okay, so now we've got the minimum camera position. And then we're gonna have to think about how to clamp it. So here we're just gonna, again, we're gonna do it brute force. Camera transform, translation, hey, what do you know? There's a clamp method. Okay. This seems too simple. Okay, let's walk through it again. Okay, so what we're doing is we're first trying to make the camera follow the player. And then we're looking at the edges of the map. Now, actually, what we could, this is actually returns something. So here's what we'll do. We're not going to do this. We're going to do this, except this is going to be player transform dot translation. And then we'll get rid of that. Okay. Oops. Okay, so we're finding the bottom left and the top right of the map and converting them to screen space. And then we are taking that minimum and maximum. I'm going to reorder these so that they're consistent. We're taking that minimum and maximum position, and we are subtracting from it, so making the space smaller by the half extents of the visible area. Right? And then we'll take the player transform. So essentially we're doing like what we were doing before. The player transform translation constrained to this area. All right, let's see if this works. So we're going to have to run left or right, top or bottom for a while, I think. Okay, so at some point, as we move around here, we should reach an edge where the player keeps going, but the camera does not. Wow, did I make this thing too big? Let's make it smaller. Let's make the map smaller. Let's make it 50 by 50. Like 50 tiles, yeah. Little Knight started their cross country. Yeah, he was going on a marathon, that's for sure. Okay. Yeah, see? Okay. So we definitely hit the left edge there. You notice he keeps moving toward the edge. But then if we get past that half part, it starts following him again. This is the behavior we want. And then if I get down here, so it was just that it was too big. Let's pick a medium size there, 100 by 100. And maybe I'll probably want to do something like 100 by 75. So you scroll sideways more. Okay, that's pretty cool. That's pretty cool. Yeah, we're still not doing that. So now that we've got our camera following our player, okay, we need a better wall. And I think we need to start generating the walls based on the map dimensions. So we can use that res map here. And let's make a quickie on here. Half extent. And that's going to take self and return an IVEC to little thing we can do there that'll help out some things. Okay. Note that this is like hard coded. Maybe it should be part of map. Maybe it should be method on map. I don't know. Okay. And then we're going to do x, negative half dot x to half dot x. And we're going to do half, negative half dot y and half dot y. So these will be the horizontal walls. Let's hold on to that. So on the, interestingly, I think we want potentially the top of the we want the top of the wall not to be visible on the top of the screen, and we don't want the face of the wall visible on the bottom of the screen. We just want the top. So maybe what we can do is this is going to be dumb, but game programming doesn't have to be elegant, it just has to work, right? So we're going to use true and false, and I could have also done enumerate and so forth, but so this is going to be y and top. Top is so let's say top of wall. So this is going to be not top of wall. Could probably reverse those. Yeah, let's reverse them, so I don't have to have a negative condition in there. Okay, so now we'll be generating for these are the horizontal walls, right? Still, and let's rename this to add walls. Let's add outer walls. Okay, so these are the boundary walls of the map, and we're building the wall. So at the top of the map, we're going to get the wall face across the top, and at the bottom of the map, we're going to get the top border of the wall. Excuse me. Okay. This is going to create a lot of entities. Let's see if we did this okay. And okay, we go up to, and notice it was a little jittery there. See if we can get up to the top. Yep. So there's the wall face, and we go down. So many daggers being thrown. The character is faster than the daggers he throws. Ow. Okay. Love that. I love that knockback effect. it's visceral in a good way. Okay, so we're actually getting dirt. But you do notice that as we get, our camera thing is still working. So as we get to the bottom here, we are not scrolling past the edge of the map, which is good. Okay. One thing that wasn't clear to me in the sprite stuff was if we could make something tile, like the texture could tile, and then we could make one entity for each wall, setting its dimensions. That would be a lot better. I mean, I think it may have to do with the texture. See, sprite, no, sprite bundle. Yeah, I'm worried. Yeah, that's sort of like a clipping thing. Let's look at the sprite sheet bundle. This we may want to switch to this later. Um, hmm. Oh, okay. So that's how you use it. Yeah. Okay. Hmm. The we might have to get into the material. So let's look at the. I believe it's the standard material. Yeah. That's for PBR. I wonder if that uses the same stuff. But maybe there's something in here that we can make use of. I haven't really gotten into the renderer side of things yet, but depth matte, normal occlusion texture. So base color texture is probably what that becomes on the standard material. Let's just look at all what they say for materials. Um, so this is just a trait, right? Because if I were coding this myself, um, I would probably be setting up this material such that the texture that gets attached to the uniform um, has a mode. Um, well, at least in GL. I don't know about WGPU, but the texture itself would say when you hit the edge, start repeating. And I would only do like so for the wall face texture or the top of the wall texture. I would say you can only repeat in the X direction and not in the Y direction. Um, but I'm not sure if this is. Okay, interesting. Okay, so you can define your own material, make your own shader. Except that sprite bundle is not giving us the opportunity to add a material to it. Interesting. Material 2S. Let's look at that. Thank you, Chris. Material 2D. I think that's what you meant. All right, let's see what implements it. For color material. Okay. Interesting. Yeah, we may have to do that. There's some question in my mind about whether we tackle this right now. Probably not. um, yeah, it looks like this is where this is the main thing that implements the material 2D. We would need to make our own probably. Um, okay, so all the methods are provided. Looks like. Yeah. There's no required methods, but that means that we could override just the fragment shader potentially. So let's look at the Bevy source for what this trait does. It's in Bevy sprite. Okay. Bevy. So nope. Mesh 2D. Nope. Okay, so here's their WGSL for sprites. Yeah, so here's their vertex shader. Okay. Yeah, so nothing really crazy there. Um, they're converting an affine matrix into a square matrix. Right. Okay. And the fragment shader is just sampling at the output of the vertex shader and then potentially adding tone mapping. And I'm assuming the default for the in color is white, which would make sense because you multiply it by whatever the sample texture is, and you get the same. Like it's an identity operation. Okay. So right, so we would want to write our own fragment shader potentially. Um, we would have to do something like wrapping on the UVs. Um, so it would compute the UV, and then if the UV is outside the -1 to 1 on either dimension, we would want to wrap it. So I suppose we could do that with a modulo operation. I don't know. Okay, that's interesting to learn. And we can. Let's see. Is this where the material 2D is defined? Sprite pipeline. Oh, that's interesting. We could look at that too for fun. Okay. Hmm. Right. Setting up the bind groups for the rendering, etc. Okay. Um, there's probably something I forget on the texture stuff in WGPU if you can tell it how to clamp or not. So that's really all we want to change about this. So okay, let's keep scrolling. This is useful stuff to look at later potentially, but think this is, we're not learning anything here. I don't see that trait in this part. So I wonder if it's in here. Nope. Sprite bundle, sprite PD bundle. Okay, well here's color material. Right, so maybe it's this. I don't know why I missed it before. Right, so yeah. These are the traits. It doesn't do any specialization. And yep, material 2D. So you can spawn a material 2D plugin with particular types of 2D materials. It looks like you can specialize that. Okay, so this, we could look at this as well. The fragment shader. Yeah, this looks like it's only specializing the fragment and not the vertex shader. So this is like just sample. We could do something similar to this, I suppose. And the vertex output is defined by something else. It looks like they've got imports. Yeah. Okay. By the way, that's all Bevy. WGCell doesn't have preprocessor anything. So they're doing that on build time. Okay. That was an interesting diversion. For now, every tile is an entity. Oh man. Okay. So we might have to, let's finish this off and make our vertical walls. So we'll do something similar to what we did for that. Yeah. Let's make our vertical walls. And it's going to look very similar. So we're going to go for y in half dot y to half dot y, right? And then we'll do something like this. So for x, left, I guess, left wall in negative half dot x and true, and half dot x false. Okay, so now we can do those. So let texture sprites wall, or no, okay, we need the if left wall. And we'll say sprites wall, and we want vwall left, else sprites wall vwall right. Okay. Okay, and then we can do this goop, exactly the same stuff. Okay, let's see if we got vertical walls. Oh, I forgot I made this 100 wide. Okay, so I think we might have a problem with that. Make this a little quicker. Let's just start from the center. It still cracks me up that I'm overtaking my projectiles. Okay, so let's go down to the very bottom as well. I want to see what it looks like when we have, yeah, so it's just turning brown. We look at those, sprites real quick. Let's see if that makes sense for how they're shaped. We picked, so the left vertical wall, and maybe if maybe it'd be more correct if I flipped it, but let's look. 15. Yeah, I actually think in this case I want to flip it. So let's say this is right and this is left. And that's not actually true. But we'll be able to see the wall rather than just dirt. And that is also a problem with these tiles. Maybe we want tile 6. Yeah, let's use tile 6 for the top of the wall. It's not correct if we have walls in the middle. Oh, that's interesting, Chris. Thanks for saying that. He says every tile is an entity is how the other tile map crates do it because it makes modifying them at runtime easier, etc. Destroying a tile or animating it. That's a very good point. I was concerned about the efficiency of it, but maybe I shouldn't worry. Yeah. Okay, so let's make these like bigger rampart like things as the bottom wall. There's still going to be some, dirt at the top, some brown spots at the top of that. But let's change that to 6. And let's go to the bottom and right and see if this looks something like what we want. You can't really see that I'm moving. Oh, I'm not. I have my fingers on the wrong key. Okay. That looks better. Yeah, okay, so we can kind of like, I don't know if that's useful. And then there's no connection between this wall and that one that makes any sense. Yeah, that's a good point, Chris. Not worrying about it until the efficiency of it is a problem. I think it was more for me conceptually like, can we think about the walls as single things? But since we're doing a grid-based game, it's not that big of a deal. Okay, and we got walls on our map, so let's go here, and we're going to need to add all of these tiles that we just used. So let's just go into assets, Kenny tiles, and we're going to add tile 1 and tile 3. Yeah, this is okay for now. Okay. And let's add our updated files. Look at the diffs. So we added the sprites for the wall tiles. We added a container for them in our resources. We're loading them. We are having the camera follow the player, clamped to the max position. I'm so glad that worked out. Sometimes when you get to these things, I'm like, oh, what's the math like? And I'm thinking about it visually. And I got a whiteboard for Christmas that I have not hung yet, but maybe at some point we'll do that, and I'll rearrange my desk so we can actually use it. So this is a good place to make a commit. So we generate walls around the playable area and make the camera follow the player. Okay. And I would like to do... like to do some stuff with, so that's our knockback. We should make this, I'm gonna go ahead and, oops, I'm gonna go ahead and open some of these files in preview, because what I want to do here, okay, zoom in. We probably want to create a rectangle for this one as a collision. Except we have kind of a limitation in our collision right now, that the size is a vec2 and not a rectangle, and maybe we convert it to a rectangle, because this size, what we would like on this particular one is for it to be centered around, or to be, you know, like this, but if we leave it, it'll just be like that. I suppose that's okay for this one, because this is just a wall that you can't walk on top of. But we will want to be able to do things like, for, let's say, which one did we use for the horizontal? So we used 40, right? So for this one, we might want the player to be able to walk up and partially overlap the wall, so that we get a little like depth effect, in which case our collision, you know, box should be more like kind of at the top of the thing, rather than being directly in the center like that, in which case you like only partially overlap the wall at best. And then if we don't, you know, include the top, we could get some weird things where something could kind of like float over the top of the wall. That would be pretty bad. So we probably need to change our collider to be, maybe have a center and a size. Okay. The other option would just be a rectangle. And then, yeah, and I mean, we do the center and the size, right? So we could have, let's do an offset. And it's not ideal, but we'll say offset is default here. Or we could just say vec2 0. No, the constant 0, please. There we go. And then we say with size and offset. Because I really want to be able to have those sorts of like finely tuned collision boxes for the for the colliding objects. Okay, so size, offset, collisions, and we'll simplify this a little bit. Size and vec2 0. And then we have, okay. And this, you know, this size one was good for our dagger, because it is basically centered. I don't remember which tile we used for that, but nice to see you, Texify. Thanks for coming. And we'll try to do it again next week. Thanks for coming. Yeah, so now we can do something like we can take. So if we're trying to detect collisions, we can take this and then add the offset to it, and that'll let us shift it up and down, left and right, etc. for the different kinds of sprites we want to do. And then we'll need to do the same here. So let's make a method to rect, and this will take a to rect at and this is going to return a rect because I want to take this basically and put it in there, and this is going to take self and a transform. And then we can do this. So we'll say collider a dot to rect at transform a, and then do the same here, except it'll be collider b to rect at transform b. Okay, so now our objects can have collision boxes that are offset from their center. Okay, so now let's think about how to do the collision here. So we want to do, let's add a collider with size and offset. Okay, so the size for the left and right walls, let's look at those. Oops, I'm going to switch to Finder here. Which tiles were we using? So the right wall is 15. Let's open that up and zoom in. So this looks like it's going to be 3 pixels wide, right? So the size is going to be I said not 2, 3 pixels, and it's going to be 16 pixels tall, right? Because it's completely vertical. And then the offset, wait, is that bigger than, here, let's do this. Let's do our rectangular selection. I was wrong, that's 6 pixels. So 6 pixels. And the offset is going to be 0 on the Y, and it's going to be offset by so 8 would be, that'd be -2, right? Okay, so what are we doing here? We're saying now this is if it's, that's if it's the right one. So let's do a little bit here. Let offset if left wall, it's going to be -2 going to the left. And this is silly, but it's going to be +2 on the right one. And we can just say offset in the collider. Okay, so and what we're using for the left one, we're using 13. I imagine it's a similar thing. Let's just be sure. Zoom in, select that. Yeah, and it's also 6x16, and yep. Okay, so I think we're good on that. Now the question about what do we do? So we detect collisions, and we're really just capturing them for the next round in our schedule. So we do collision detection at the end, and then we handle it in the process combat phase. And we're only allowing knockback collisions between the player and the ghost. What we would like to do is not knock back the player when they hit a wall, but just prevent them from going past it. And I do want to wrap up real soon. I think this is maybe too much. But at the very least, let's commit this a little bit in the collision. And I think in my last commit, I didn't add the map module. Okay, yeah. Okay, so let's maybe commit this adjustment to the collision detection, and yep. Okay. So this is allow colliders to have non-centered bounding boxes. Okay. Right, and I think I actually messed up that commit because it has this in it. So let's let's go ahead and finish that out and give the do the same treatment up here. Top of wall. Then we're going to look at which one? Not these. Not that. And we're going to need to do the, maybe we'll just do it in here. Be a little bit weird. Okay, if it's the top of the wall, else. Okay. If it's the top of the wall, then we have the size is 16 by 12. And the offset is going to be -4. And then for the bottom of a wall, like I mentioned before, we want to give them the opportunity to kind of like overlap on it. So let's do something like, if I can get my selector right. Let's do 16 by 8. And I think my math is wrong here because this needs to point at the center of the wall or the center of the box. But let's do this one first. So vec2 new 16 by 8, and this is going to be vec2. So that's going to be offset of 0 and 4, and I think this one needs to be -8 because that was shorter. 0. Let's look at that again. So if the center, so that's the center. No, it is -4. I was wrong. But I think that it might be more on this one. So no, we would only move the center up by 4 pixels. Okay, I think I'm comfortable with that. It's just I didn't expect it to be the same. I thought we would be going a different direction there. Okay, so now what I want to see, and like there's not going to be any logic that is going to push the player away from the wall. But I want to maybe, we can do it in here. This is going to be another one of those cross-cutting things where I started throwing things in combat, right? And I think there's some stuff in health, right, where we're saying, hey, these specific entities can take damage from one another. Bye, Isaac. Thank you for coming. I'm sorry I didn't see your chat message. But this is a collision that maybe this would be good for movement. Yeah, I think we can spend the time to do that. Let's fix collision boxes for walls. And I think what I'll want to do is, yeah, let's go in movement, and maybe what we'll do here is say, this is hard to say because this is a collision related thing. But if we're updating the position, and what does our movement plugin do? Yeah. I want to say keep inside walls. We're going to chain those. So like our velocity will probably have effects like things getting stuck on, sides or corners, which we'll have to deal with. But I want to make this a separate system. because it needs different things. Like this is just plain movement. This is going to be we want to adjust the transform if it's colliding with something. So, and it's not combat, right? And collider, and it's not a wall, right? And then we want a query yeah, we want this to have velocity, because otherwise how is it going to collide with anything? We don't want to care about things that are stationary, right? So it has a velocity and a collider, but it's not a wall. This is going to do weird things with our weapons. Maybe what we should do rather than that is say, like we did for the take damage system, let's make this generic over a component. This be our marker component. And this query will be with T. Excuse me. And then we'll want to do, say walls is another query. And we want to get its transform and collider. And those are only walls. Okay. And we need to import all that goop. Why is it not complaining yet? Let's see. What did I mess up there? Oh. Does it need another paren? Oh, shoot. I hate it when this happens. Okay, let's get those on separate lines. Okay, so we're going to chain those together, and then we're going to keep them in set, and there's the closing that and closing add systems. Okay. Now we've got problems. Okay, so let's import that, and let's import that. And that needs to be a borrow. Okay, so we need our to keep inside walls to start with player. And let's also do it for ghosts. Okay. So, what we don't want is for our weapons to just like hit a wall and then get stuck. That would be really weird. Honestly, we probably want to despawn them when they collide with walls, rather than keeping them inside. So we'll have to figure out how to do that later. Okay, so our goal here is to detect if any of the collisions are with a wall. Okay, so we'll say for transform collider in query dot itermute. Okay, so we'll start with that, and then we're going to loop through all the collisions. Why is it not? Okay, well, let's just say collision in collider dot collisions. Right, so that's going to return an entity. Okay, so then we can say wall transform wall collider walls dot get collision. So this is, obviously not as efficient potentially, because we're going through all the things that it collided with and saying, is this in the walls? I don't know if there's any better way to do that, but with the way our collision system is set up right now, this is what we do. Not great. Okay, so if we're able to get this, then what we want to do is say, we want to make sure that the bounding box of the item that we're trying to keep from hitting the walls is outside the bounding box of the wall bounding box. I just said bounding box twice. Okay, so it might be good if I drew a picture here so I can think about it. We have sketches. Let's make a new. The bounding box. Yes, exactly. See, you understand. Here. So actually, we can sort of make this right. We want to. This is related to our knockback discussion, but it's the same sort of thing, except we're not applying it over time. We're applying it instantly. So what we can do is go look at what we did there in the knockback. So we gave it a displacement. And this was really what we did is we took a unit vector, right, of the differences of the overlap, I'm guessing. No, it was center to center. And then multiplied it by the knockback distance. Yeah. Okay. And we did something similar here with the, looping over the collided entities and say, is it in there? What we might do in this case, I think, is so I'm trying to think about we could do the center to center vector again. That would give us the direction the object that is running into the wall should be pushed away. But it won't give us the magnitude um, of that vector. That'll just give us the the distance between the two. We might need to draw some pictures still. All right, let's go back to our diagram here. So what I was thinking is maybe we could get the intersection of their bounding boxes. That's not right. I was going to say, because this is like, in this case, the orange over the green, what we want to do is move it. I guess we could move it by half of the. Actually, let's do something simpler. So, okay, so we can get the rectangle of the collider for each of these, right? Um, and then what we should do is see how much in each direction it's overlapping. So we don't care about the center to center vector yet. We will only care about the signedness of that, right? Okay, so let's get the object rect, and we can actually do that up here. Collider that to rect at no transform. We're gonna immutably borrow that. Okay, and then we'll get the let wall rect, basically doing the same thing. Wall transform. Okay, so now we can go. Let's get the overlap. Is object rect dot intersect with the wall rect, and we don't actually care about the how much to put this. This will tell us, the overlap will tell us how much to push it away, right, in each direction. We just need to know let's see, dot, can I get width? Yeah, I can get width, right? So we can do like there's something on vec2 which is signum. So this will give you -1 in the x direction if it's negative, +1 if it's positive, and same with y. So we can go let's say push. We're just going to do this brute force, and then we'll make it more elegant in a minute. actually, no, this is, let's say, just call it push away. This is going to be vec2 overlap dot width overlap dot height. And then we're going to multiply it by, we'll say extend with 0. So it's a vec3, right? Or we can just do vec3 new. That's probably the better way to do that. Okay, and then we're going to multiply it by the object, so the transform translation, and we need to think carefully about the direction here. So we want to subtract the wall transform translation. Signum, right? Okay, so this is going to say we're getting a vector between the centers of these things, right? Which may not be exactly what we want to do, but hold on a second. Maybe if we look at the rectangles, can you get the center of the rectangles? That might be better to do. Yes, you can get the center. Okay, so we'll do, I love it when they've like thought about these functions, these things you would want to do, and made really nice functions for them. Okay, so we're going from the center of the object rectangle to the center of the wall rectangle. So that'll give, I'm sorry, we're subtracting. So in the case of our picture here, that would be, we're getting a vector that ends here and starts here. So we're basically getting this one, but offset. And then we'll do signum on that. Okay, so that's our 2D push away. So now we can say we can offset the transform of the original object by that amount that we pushed away. I think what I'm learning about game programming is you really need to like to do math, geometry. Okay, let's put a little. Yeah, thanks, Chris. You appreciate that. Okay, so let's put a little info in here, and so that when we collide with a wall, when something collides with a wall, we'll see it print out on the console. And then this is a great place to stop the stream because I'm getting tired. Okay, let's cargo run that. Oh, what did I do? Is this our overlapping thing again? Yeah, yeah, we have that same problem. Okay. So we need to exclude even though like we are being really explicit there, we need to exclude the wall from that. What's wrong with my query there? Ah, complex types. Okay, Chris, how do I put this in the cargo tunnel? Am I gonna have to look it up? Because this is the second time we're having to do that. I think it's. I think source of Z is no help here. Let's look it up. Cargo toml lints. Okay, lints table. I'm not using nightly. Oh, work for me, please. That was 8 months ago. Okay, that's been stabilized. Okay, so let's look at. So lints clippy. Okay, that's what we'll do. Lints clippy. And this is, what did we do in that other one? Was it in camera? Yeah, type complexity. Okay. Allow. Yeah, I suppose I could do that in one line, but let's just do that and remove it from the camera module. Okay. Thank you for cluing me into that, Chris. That'll be useful. Okay, let's see if that fixes that thing. Yeah, okay. So we're going to run up here and probably going to get something else hitting the wall. Actually, we only coded it for the player. So yeah, look, we've got all sorts of goop going on there. That is actually pretty trippy. We will want to probably do this in a separate. Maybe do this in the collision. But like that is very undesirable behavior. We might do this in the combat, but let's see him hit the right wall or the left wall. So yeah, and notice how he jiggles around, because we're offsetting them. Yeah, that is funny. Okay. Okay. But we also, you can kind of move on top of the wall a little bit, as well as on this upper one. You can kind of move. Yeah, he's freaking out. Why are you beating me up? Cool. All right, this is a good place to stop the stream. Thank you for coming. Thanks for all your help, Chris, as always. Love it when you join. Someday we'll actually get you on audio if you're willing, but maybe for another day. And we made some progress. I'll push up the commit of what we just did, and then maybe next time we'll refine the that particular collision algorithm, so that it's a little bit less janky, and that we are not needlessly pushing away the player in multiple directions. So, all right, have a good one, folks. See you next week.